All right. So we're recording. We'll know we're recording because that little light's blinking up there. Okay. Now, I'm not stopping and starting between questions because you asking questions is just as helpful to someone that's watching it as anything. Okay. So these get a little bit longer because it's just like sitting in class. So if you're ever out, use it as that. Okay, you can turn it on, sit there, it's like sitting through class, I hope. The unit circle, which is what you've got drawn there. Now they're saying unit because that's the radius of this circle, 1 unit. What unit? It doesn't matter what unit. 1 foot, 1 inch, 1 mile, whatever. 1 something. 1 unit. What's the significance in that? We'll get into that a little bit more later. I don't want to get too far ahead. Okay? So, how do we use the unit circle? There are points that we can find on this circle that are of importance to us. For instance, this point right here. Let me do a black ink instead of red ink. This point right here. Could you tell me the coordinate of that point? Yeah, you can. Think just a minute. You can tell me what the coordinate of that point is. 1, 0. How do you know that? Because it's a 1 unit long, it's a 1 unit radius, and it's on the x-axis. So it's to the right, how far? 1. How far up and down did it go? 0. What would the coordinate of that point be? How much? 0, 1. Coordinate of this point would be -1, 0, and the coordinate of this point would be. All right, on your unit circles, you can start filling in some of these coordinates. Now, there's some other ones we're going to look at. And the thing that we have talked about from the past already, 30, 60, 90s, and 45, 45, 90s. Okay? Those are special right triangles. We've talked about those. We know the relationship that exists between the lengths of sides and such, correct? Okay. Now, we're going to talk about those also. Let me jump up to this next screen and then we're going to come back to this one. They're giving us a concept right here of cosine and sine of angles, and they're giving us coordinates that go along with them. I want to show you where that comes from. Okay? Back to my unit circle. If I were to draw a 30-degree angle right there, I can find the coordinate of that point. How? Why? For one thing, how long is the radius from there to there? One. Because this is a what? Unit circle. So any radius I draw in this thing is going to have a length of 1. So I know that that is 1. Does that make sense? Algebraically, the coordinate of that point, do I know what the coordinate of that point is? Say no. No, you don't. But I know it has a what? X value and a Y value. That's the way coordinates of points are made, with an X value and a Y value. How far do I go out the X axis to get to that point? I go X far. How far up from the X axis do I go? I go Y far. Does that make sense? Which means I can label that as X long and that as Y long. You with me? If that's a 30-degree angle and I do things this way, that means I have just made myself a right triangle, have I not? And what kind of right triangle is that? A 30, 60, 90. And I know how to find lengths of things in 30, 60, 90s if I only have one part, and I do, I have one part. What part of the 30, 60, 90 do we have? The length of side. Which length of side do we have?
X.
No, we don't. It's called X.
What is the radius?
The radius, which is what part of the 30, 60, 90? When I'm saying parts, what am I talking about? I'm talking about the sides. How do I identify sides in the 30, 60, 90? I call them what? No. What did we call them? When we was talking about 30, 60, 90, we identified the three sides, and they had three names, and we identified them as, give me one of them. Hypotenuse, short leg, long leg. Hypotenuse, short leg, and long leg. Which of those parts do we have? The hypotenuse. We have the hypotenuse. The other two parts.
Teachers, please check your emails at this time. Please check your emails at this time. Thank you.
Here we go. So, as we were talking before lunch, if I put a 30-degree angle in there, and I draw a hypotenuse, and I understand or represent it algebraically as the length of that side being X, because it's along the X-axis, and the length of that leg there being Y because it's following the Y-axis. Algebraically, the coordinates of the point that's located right there is XY. Is everybody with me on that? What we were talking about is recalling back what we know from the past, that we have just created a 30, 60, 90 triangle, and the part of the 30, 60, 90 triangle that we know is the hypotenuse. And I was trying to get out of you before things happen, what do we call the other two parts? Short leg and long leg. Short leg is always going to be somewhere. Where is it? Opposite of the 30-degree angle. So the Y leg is also the short leg, which means the other part is the long leg, and it's always opposite the understood 60-degree angle. Long leg. Does everybody remember that? How do you go from the hypotenuse to the short leg? Somebody remember the pattern. 30, 60, 90 triangles. How did we go from the hypotenuse to the short leg? Divide by, come on guys, from the hypotenuse to the short leg in the 30, 60, 90, how do you do that? Divide by 2. Divide by 2. Y'all don't remember that? From the short leg to the hypotenuse, you multiply by 2. So to go from the hypotenuse to the short leg, you divide by 2. Well, what is the hypotenuse's length? 1. So when you divide by 2, I'm going to step right over here. Y would be how long?
All right.
1 divided by 2. 1/2. How do you go from the short leg to the long leg in a 3069? Multiply by what? The square root of 3. You multiply by the square root of 3. So the x would equal to 1/2 times the square root of 3, which we could rewrite as square root of 3 over 2. So x equals square root of 3 over 2. Does that make sense? Which means the coordinate of this point is square root of 3 over 2, 1/2. Unit circle, you can fill something in. We can fill in the 30-degree angle, and we can fill in the coordinate of the point. Now there's another blank that's there that we're not going to fill yet. So the one that has the little degree mark, you can put 30 degrees there, and the coordinate of the point. So we can put 30 degrees, and we can put the square root of 3 over 2, 1/2. Also around, you have filled in those around. Okay? Is everybody with me on that? Now, what?
Can you say what I'm going to get from this part?
30, 60, 90 triangles. We have the hypotenuse. We can find the short leg by dividing by 2. The pattern is the short leg times 2 is the hypotenuse. The short leg times the square root of 3 is the long leg. So if I have the hypotenuse, I do the opposite. I divide by 2 to get to the short leg, multiply by the square root of 3 to get to the long leg. Now, with that being said, this is where this unit circle stuff starts coming into play. What is the pattern for sine? You remember what the pattern is in a right triangle for sine? Sine of the angle equals what? What's the pattern? Sine of the angle, we'll call the angle theta, is equal to, what's the pattern for sine? Opposite over hypotenuse. Guys, I'm trying to teach y'all something and progress on things that we're supposed to already know. Y'all are going to have to do a little bit better effort of trying to recall some things from the past. If I've said it once, I've said it 1,000 times. Just because we pass it, don't mean we're not going to use it anymore. I can't, it's going to be next to impossible for me to get you to understand this unit circle. And the reason is because you won't try to remember 30, 60, 90 triangle stuff from a month ago. I know it's been a while. I get it, but y'all are acting like I've never even talked about it, and we spent 3 weeks on it. Sine of the angle is equal to the opposite over the hypotenuse. If I go down here to this triangle, which side is opposite of the 30-degree angle?
The short leg.
Which is also identified as y, correct?
Yeah.
So, which we have said has what measurement? A half. So the sine of 30-degree angle is equal to the opposite, which is a half over the hypotenuse, which we know has length 1. Anything divided by 1 is what?
Still the same.
Itself. So a half divided by 1 is a half. Which means the sine of 30 equals a half. Which means in the coordinate of the point, that is sine of 30. So the sine of 30 is the same thing as the y-coordinate of the point. Does that make sense? Which is equal to 1/2. If I do cosine of 30, cosine of an angle, what's the pattern for cosine of an angle? Adjacent over hypotenuse. In this particular problem, whenever I have an angle to plug in, the cosine of 30, what is adjacent to the 30? The x. What did we say x was equal to in this problem? Square root 3 over 2 over the hypotenuse, which we said was 1. Anything divided by 1 is itself. So the cosine of 30 is equal to the square root of 3 over 2, which means the coordinate cosine of 30, sine of 30 is the same thing as the square root of 3 over 2, 1/2, which is the x coordinates for and y coordinates for the values of sine and cosine of 30. Does that make sense? Which brings us to the slide that I jumped up to and then jumped away from. If I have an angle, the coordinates of the point are the same as the cosine of the angle and the sine of the angle. You with me on that? So, what are the cosine and sine for theta being negative 360? Well, what do I need to find that goes with negative 360? The coterminal angle between what degree measures? 0 and 360. So what angle measure has the same coterminal side as negative 360? What do you do? Add 360 and get 0. What are the coordinates? Look at your circle. What are the coordinates of a 0 degree angle? 1, 0. Right? What does the first coordinate represent? Cosine of the angle. And the y coordinate represents sine of the angle. Now here's the thing. This is the part I'm trying to get y'all to comprehend. Negative 360 degrees has the same coterminal side as a 0 degree angle. Are you with me on that? Since they have the same coterminal side, then that coordinate of point is going to be the same. So finding the sine or cosine of negative 360 is exactly the same thing as finding the sine or cosine of 0. Our circle has a 0 degree angle on it. It does not have a negative 360 degree angle on it. So I've got to convert from the negative 360 to 0 get my measurement, and then I can apply it to negative 360. Does that make sense? So the cosine of negative 360 is what? One. How come? The first coordinate in the point is the cosine. The second number in the point is the sine. I converted negative 360 into an angle that my unit circle has on it. You with me? So what is the sine of negative 360? Everybody with me there? 180 degrees. Do I need to convert that into another angle? No, why not? It's between 0 and 360. So I can use it directly because it's going to be on my unit circle. What is the coordinate of the point for 180 degrees? Negative 1, 0. So what is the cosine of 180 going to be? What is the sine of 180 going to be? Please don't make this hard. 450 degrees. What am I going to have to do there? Subtract 360. So 450 minus 360 is 90. So the coordinate of the point at 90 degrees is, so the cosine of 450 is the same thing as the cosine of 90, which would be, and the sine of 90 is, not 90, 450 is, does that make sense?
Yeah.
Now, I did one for you for a 30-degree angle just a second ago. They're doing the 60-degree angle here in this illustration. If I were to draw a 60-degree angle up to the point where it crosses the unit circle, and then draw it down and create the right angle, I have created an X value and a Y value, right? Just like I did before. Which part of the 30, 60, 90 do I have? When I say part, I'm talking about what? The lengths of the sides of the triangle, the hypotenuse, the short leg, and the long leg. Which part do I have? No, the hypotenuse. What are the other parts? Short leg and, now the short leg and long leg are going to be in different spots this time because the 60-degree angle now is down there. Where's the long leg going to be? Opposite of the 60. So this is the long leg. The short leg is down here, right? So in this example, Y is the long leg and X is the short leg. Does that make sense?
Yeah.
So I have the hypotenuse. How do you get to the short leg from the hypotenuse in the 30, 60, 90? Divide by 2. So the X, which is down here, X is going to equal the hypotenuse divided by 2. So X is 1/2. How do I get the long leg in a 30, 60, 90 from the short leg? Multiply by the square root of 3. So y is the long leg. It will equal to the short leg times the square root of 3, which would be square root of 3 over 2. So the x and y coordinate of a 60-degree angle is going to be 1/2 square root of 3 over 2. Something you can label on your circle. Which mark is that one going to be? Which line is that going to be in your circle that we've got? It's going to be this one right here, 60 degrees, and what's the coordinates of the point? A half square root of 3 over 2. Does that make sense? What do you think we're left with here? We've already got the 90. We've already got the 90 degrees. That is at 0, 1. We've already got 0 degrees. That's at 1, 0. And that's the same thing as 360 degrees, correct? Which is also at 1, 0. And here is the 180 degrees, and it is at negative 1, 0. Right? So we got this one down here is 270 degrees, and it's at 0, negative 1. So those are the things that we have marked. We found the 30, we found the 60. What does that leave me with right there? 45. 45 degrees. So in my circle, this is a hand drawn. Here's my circle. It's 1 unit. If I draw a 45-degree angle that is 1 unit, and I put that down, tell me what's true about the legs of this one. In a 45, 45, 90, what's true about the legs? They're the same, because what kind of a triangle is it? Isosceles. If that's 45 and that's 90, that has to be 45. Yes, it's got an x and a y coordinate just like the others do, but the legs are the same length, so in this particular case, the x and the y turn out to be the same amount. How do you go from the hypotenuse, which is what we have, the length of 1, to the length of one of the legs? It's not the same as a 30, 60, 90, or it'd be a 30, 60, 90. How do we go from the hypotenuse to a leg in a 45, 45, 90? Divide by square root of 2. So x is going to equal the hypotenuse divided by the square root of 2. We don't leave square roots on the bottom of the fraction. What do we do? You remember how you get rid of that? Multiply the top and the bottom by the square root of 2. 1 times the square root of 2 is the square root of 2 times the square root of 2 is 2, because it's the square root of 4, which is 2. So x value is square root of 2 over 2. And because we've identified its isosceles, y has to be the same, so I don't have to go through the hassle of finding the y. The y is going to be the same thing, square root of 2 over 2. Does that make sense? Yeah. So, back to my drawing, a 45-degree angle has coordinates of square root of 2 over 2, square root of 2 over 2. That makes sense. Now, you can find the rest of those and not have to do what we just got through doing. Because this circle is symmetric. It's going to be symmetric across the y-axis and across the x-axis. So if I were to fold this side over here, what would that fold over here to? What angle measure would that be? If it's 30 over here and I fold it over, what angle would that be? If that's 180 and from there to there is 30, what does that angle have to be? 150. What would that angle be? 135. What would that angle be? Is everybody with me on that? What would these three angles be down here in the third quadrant? How much? 210 is the first one. What would this one be? 225. And this one would be? We've got the 270 already. Let's go over to the fourth quadrant. What would those angle measures be? 300, 315, and 330. Does everybody understand how we got those measurements? Basically by adding, subtracting 30 or 45 from one of the coordinates that we already know. Now, the coordinates of the points, we can also get those by what we already know about symmetricness in the coordinate plane. If that point is square root of 3 over 2, 1/2, what would 150s have to be? Yes. Negative the square root of 3 over 2, 1/2. How do you know that? Because what's the only difference from points in the first quadrant to points in the second quadrant? What changes? Of what? The sign of x is the only thing that changes. X is negative over here. What would the coordinate of the 135 be? And square root of 2 over 2. What would the coordinate of that one be? Negative 1/2. Square root of 3 over 2. Take a second and fill in the rest of those real quick. Hurry. Rob, what'd you get for that one? This one right here, what'd you get? The 210-degree angle, what'd you get the x and y coordinate to be? Which one of these is it going to be corresponding to? The 150. What's going to be the difference in that point when I flip it across the y-axis? The x is going to stay negative and the y is going to change to negative. So negative the square root of 3 over 2, negative 1/2. What's the coordinate of that point going to be? Negative square root of 2 over 2. Negative square root of 2 over 2. What's the coordinate of that point going to be? Negative 1/2. Now filling in the fourth quadrant. What would the coordinate of the 330-degree angle be? Square root of 3 over 2 is positive because x is positive on this side, right? It's below the x-axis, so y would be negative. What would the coordinate of 315 be? Square root of 2 over 2. Negative square root of 2 over 2. And the 300-degree angle. 1/2 negative square root of 3 over 2. Guys, you need to start memorizing this circle. Now here's the thing. How much of this did we actually have to find the measures for? Them 3 over here. And we're able to take these and convert them to the other ones, correct? Now, there's times, because the angles go all the way around to 360, I just went ahead and memorized the circle. It's going to take a little effort. You're going to have to actually sit down and do it. It don't just automatically stick to your head. You're going to have to put some effort in it, but I'm telling you, it's going to make your life a whole lot easier if you do. So that ought to be something you start doing, is memorizing this circle. If I ask for what's the cosine of 30, what's the cosine of 30? Square root 3 over 2. How do you know that? Because it's the x-coordinate of the point that's on the 30-degree angle. What if I ask for the sine of negative 225-degree angle? Negative square root 2 over 2. The y value of the point at at 225 degrees. Y'all with me? So there are the examples for finding those. So here's a question. What are the sine and cosine of these angles? Go. Give me the sine, cosine of 135 and the sine of 135. The cosine of 300 and the sine of 300. What would it be? Well, you've got that paper, look at it. I just showed you how to do it.
Negative square root of 2 over 2.
For cosine, what'd you say?
Negative square root of 2 over 2.
Why? How'd you know it was that? X value of the point at that degree measure. What's the sine of 135?
Square root of 2 over 2.
How come?
That's the y value.
It's the y value of the coordinate of the point at that angle measure. What's the cosine of 300? A half. What's the sine of 300? Negative square root 3 over 2. How did I know the cosine of 300 was a half? It's the x value of the point at that angle. What's the sine of 300? You said it was negative the square root 3 over 2. How do I know? It's the y value of the point at that angle. Page. $832. No, wait, wrong page. 840. No, that's right. 832. Page 832. We did through 25. I want us to do 26 to 33. Oh, that's not very many problems. That's only, what, 7 problems? They ought to be pretty simple if you follow along here with your stuff.